Good evening, my YouTube viewers. In this particular video, I'm going to be talking about a sample distribution. And so we're going to discuss the sample distribution of the sample mean because it will form a normal distribution because of the central limit theorem. So the central limit theorem just states that it doesn't matter what the distribution is. If it gets sampled enough, the means of the samples are going to form a normal distribution. So what we're doing is a sample distribution of the sample mean. So, and we're going to be doing this in Python. So in order to execute the program, what we're going to need to do is we're going to need to import two libraries that are going to help us to execute the program. So we're going to import NumPy as NP, which is the numeric library, and then we're going to import matplotlib.pyplot as PLT, which is the visualization library. So we're going to generate a population data with a normal distribution. And so the way we're going to do that is we're going to set our seed. So when we set the seed, basically what we do is every time you run the program, it initializes to the same numbers. That's what happens when you set the seed. So we set the seed with np.random.seed, and then you can put any number you want in the brackets, and I just put 42 in there. Okay, and so the population, we're going to define the population as np.random.normal. Log equals 50, so that's your mean. Scale equals 10, that's your standard deviation. And size equals 10,000, and that's your sample size, or that's how many numbers it's going to generate. And now we're going to set the parameters for sampling. So the sample size is 30 and the number of samples is 1,000. And then we're going to collect the sample mean. So the sample means is an empty list. And then we're going to create a for loop for underscore and range num samples, and that's 1,000. So that means the for loop is going to iterate through 1,000 times. Sample equals np.random.choice, brackets, population, comma, sample size, comma, replace equals false. So that means it's going to sample it, I think, let me just see what it's going to sample it. It's going to sample it 30 times, and then whenever it takes a sample, it's not going to replace it. And sample mean equals np.mean sample. And then what you're going to do is you're going to append the sample mean to the list called sample means. And since the for loop is going to iterate 1,000 times, what's going to happen is you're going to have 1,000 sample means in the sample means list. And now what we're going to do is we're going to plot the sampling distribution of the sample mean. So we're going to do that by creating a histogram. So plt.hist, bracket, sample means, comma, bins equals 30, comma, color equals sky blue, comma, edge color equals black, comma, alpha equals 0.7. And then plt.axv line equals brackets np.mean sample means, comma, color equals red, comma, line style equals dashed, comma, line width equals 2, comma, label equals mean. And then you have plt.axv line brackets np.median of sample means, comma, color equals green, comma, line style equals dashed, comma, line width equals 2, and comma, label equals median. And now we add titles and labels to the histogram. So the title is going to be sampling distribution of the sample mean. The X label is going to be sample mean, and the white label is going to be frequency, and you're going to have a legend, and then we're going to plot it. And so this is it, the sampling distribution of the sample mean. So you can see the median and mean in red is 50 because you set it up for 50 when you defined your normal distribution. And then the median is 50.04, so it's just slightly different than 50. So you can see we did create a normal distribution, but initially, but whenever the samples are going to create a normal distribution as well, because you had 1,000 samples, and so they're going to create a normal distribution as well. So that concludes this particular video, and I will be giving you another video on a distribution very soon, so watch this space.